start with what we mean by vectors first, okay? So, what are vectors? Cecilia, go ahead, please.
Quantity with magnitude and direction.
Thank you, right? So, those are any quantity with magnitude and direction, such as force, that's mass times acceleration due to gravity, or just basically acceleration. Velocity, that's the speed on a certain direction. Acceleration, displacement, all of these are physics quantities that all involves two, the magnitude and the direction. For now, we'll be working on the following here. First, how to determine vector from given points. And second, bless you, how to determine the magnitude and direction of a given vector. So, let's start with the first one in here and figure out on how we can work on numbers, what's this? 12 and, 12, 14, okay? All right, let's read number 12. Okay, let's read this number 12 and see how we can work on that one, all right? Jillian, go ahead, please. Number 12. The instruction first. For the following exercises.
For the following exercises, determine whether the two vectors u and v are equal, where u has an initial point p1 and a terminal point p2, and v has an initial point or p3 and a terminal point p4.
Thank you. So, how do we work on this one? Okay, so how to determine the vector from given points? As you may notice in there are 2 points given. So let's read our step number 1, okay? Addie, go ahead, please.
What is the initial P1 and terminal point P2?
Thank you. Okay, so in this case, we have, let's try that one for vector u. So for vector u, what is the initial point? For vector u, the initial point is P1, and P1 is at point 1, 3, 7. So that's your x1, y1, right? Okay, so it's the x and y coordinates of the initial point P1. Okay, we're going to do the same for the terminal point P2 of u. So it says in here, u has initial point at P1 and a terminal point of P2. And P2 in here is what? 2, 1. So this is our x2, y2. Okay, so again, that's where it started and that's where it ended. Now, how to get the vector now? What do we do with these two? Initial and terminal points. Let's read our step number 2 and continue with this, all right? Jalen, go ahead, please. Express
Vectors as
yep, x2 minus x1.
x2 minus x1 and y2 minus y.
Thank you, right? Again, so simply get the difference, thank you, between the x and y coordinates, okay? Terminal minus initial, all right? So again, it's terminal minus initial. So, and again, as you may notice in here, we're using that kind of bracket, all right? Okay, so that's our vector bracket. And we'll use the formula, okay? x2 minus x1, how much is that gonna be? 2 minus 3. Negative 1. Okay, so again, 2 minus 3, that's terminal minus, terminal minus initial. And the same with the y, 1 minus 7, negative 6. So that will be our vector, negative 1, negative 6. And the last one in here is plot the vector, right? So how do we see this vector now, okay? So here it is. I'm going to plot those 2 points in here first and see how it looks like. The first point is what again? 3, 7, right? So 3, 7. That's let's call it P1. Okay. P2. P2 is, what's that again? 2, 1. Okay. 2, 1. Oops. and label in here P2, 2, 1. Okay. Now, where is our vector now? So to draw our vector here, here it is. So to draw our vector here, this is what we're gonna do. Okay, so to draw our vector here, from the initial point P1, and to the terminal point P2, we're gonna draw this, oops. So the tail of the ray, this we call it ray, right? The end point of the ray or the tail of the ray will be at P1, and the arrowhead of that ray will be at the terminal point P2. And as we may notice in here, this is basically our -1, -6. So where is that -1, -6 from here? So this is what we're gonna do to analyze this one, okay? I'm gonna draw a right triangle out of this, okay? So from here, I'm gonna draw a right triangle from here to here. Let's color it green, okay? A right triangle here with the horizontal and the vertical. And as you may notice with that right triangle, from here to here, it went 1 unit to the left, okay? So that's 1 unit to the left, which means that is your -1, okay? And then from here to here, let's count. As you may notice, this is by twos, okay? So from here, 1, 2, 3, 4, 5, 6, okay? Did it say in there 6? Okay, so as you may notice in here, from here to there, that's 6 units down, okay? So that's what? -6 in there. So what we mean by that vector -1, -6 means what? That from the initial to the terminal side or points of this vector, you went with what? 1 unit to the left and 6 units down. Okay, that's -1, -6. Questions? We can also write this one in terms of unit vectors. The horizontal, okay, the horizontal movement can also be called the unit vector I. Okay, those are the horizontal unit. So that means that that one can be written as -I, okay, -1I. And then in here, how many unit vectors down? Those are what we call J instead, right? So J in here are what we call our vertical units for the vector, vertical vectors. As you may notice, it's 6. So this can also be written as -I minus 6J. In short, -I meaning 1 unit to the left, and -6J meaning 6 units down on its what we call vertical component. Questions with what we did with that one? Also, according to superposition of vectors, okay? So when you say superposition of vectors, you can superimpose, right? That's what we mean with superposition. You can transfer this, move this anywhere, and as long as the vector is the same, that will be the same vector as well. So in short, according to our superposition of vectors, I can basically put this one on the origin, okay? Go 1 unit to the left, go what again? 6 units down, okay? 1, 2, 3, 4, 5, 6. So that's what? Negative I. And then this is what? Negative J, negative J, negative J, negative J, negative J, negative J. Short 6 units down. Connect those two. Then that means this initial side and that terminal side, if I connect them, this and this two are the same vectors as well. So this can also be called vector what? Negative 1, negative 6. Or the same, negative I minus 6j. Yes?
I have a question. For the alternate form of the vector, you know, the one that has I and J,
Yes.
do you need to put parentheses or specific, like parentheses things around
Very good
it?
question, okay? So here, we only use what we call these two parentheses in here. We call them like what we call the vector parentheses. It looks like arrowheads, right? However, if you write those in what we call unit vectors I and J, you don't need to put them in parentheses and comma anymore, right? So we can say that these two are basically same vectors, just different notations. So think of it as what? Just different notations, but basically expressing the same exact vectors in two different ways. Okay? Okay. Questions now, please. Okay, and the next one is, what if we do the reverse? Okay, what if we are now given a vector? How do we get the magnitude and direction of such? So let's see in here how we can do that for this problem, this particular problem. Okay. Okay, we have numbers 61 and 62 in here, and see how we can solve for these two scenarios, all right? Let's just read one of them. Doesn't matter, 61 or 62. Camario, go ahead, please. Okay. Any of those two real-world equations, applications.
A woman leaves home and walks 3 miles west and 2 miles southwest. How far from home is she, and in which direction must she walk to head directly home?
Thank you. Okay, so it says in here, a woman leaves home and walks 3 miles west. Okay. After that, she walked again. How many more miles? 2 more miles southwest in this case. Okay. The question now is, how far from home is she? So that's the distance, what we call the magnitude. Okay. Also, and in what direction must she walk to head directly home? Okay, guys. Okay, let's see. Let's draw it first, right? So it says 3 miles west and 2 miles southwest, and this is number 61. Okay, so ready, guys? Let's draw it first. Okay, so we'll go back in here. Okay, and then let's draw it in here first. Okay. Bless you. Let's remove these two first. There we go. Okay, so it says what? 3 miles west. So if we started here, okay, so it's better to like start at the origin. Okay, there we go. Start. So the woman went 3 miles west. So where is that? Good. So
Isn't west the other
3
way?
miles west. Where's, oh, yeah, my west is, okay, sorry. So this is east, but if, okay, west, okay, so east, west is in there, okay. Thank you. Let's go back, right? Because it looks like my west is your east and your east is my west, but yeah. Okay. You know what? That's good analysis, right? We have different orientations of our east and west. But anyway, so yes. So 3 miles west, there we go. Good. Okay, so that's the first vector. Let's call it V1. Okay. The second vector, after that, she went where?
2 miles.
2 miles. 2 more miles southwest. So where's the 2 more miles southwest? So that means this is what I'm gonna do. I'm gonna draw in here another directional plane. Okay, that's north, east, south, and west. This time she went where? 2 miles southwest, right? So from here to here, yeah, so somewhere in here, right? Okay, and that will be southwest. So that, which means that this one in here can be said to be how many degrees? When you say southwest, 45 degrees, right? Okay. Well, basically, since from south to west is 90 degrees, then we can say that southwest is like, like halfway of an angle, right? Midway of an angle between them. So we can say, a 45 degrees on what quadrant? 3, right? So if that's quadrant 3, we can also say that from here to here, that's gonna be what? 225 degrees, if you want to see it in that way. Get it? Okay, now, how do we do this? Okay, so here it is. To do this one, first of all, let's analyze our V1. Okay, so for our V1, let's read this one first. Kendall, go ahead.
Determine
Vector AD, right?
A,
So,
B.
thank you, right? So in short, just express each of the vectors in terms of its x and y components, right? So for V1, what is your vector V1? -3, 0, right? Get it, guys? Why -3, 0? Okay. Because it went directly left, directly west, 3 units. So this is what? 3 miles west. Yep. Now what's our V2? So here's our V2. It says 2 miles southwest. So with that being said, what's the x coordinate? That is 2 miles x coordinate. So that's what? Cosine of how many degrees?
45.
225 degrees. But yes, that's 45 degrees on the third quadrant, right? So yes, you are correct. 45 degrees. However, since it's in the third quadrant, right? So we made it 225 degrees. Okay. What about for the y? Same. 2, right? Sine 225 degrees as well. And again, this is what? 2 miles southwest. And again, if you see southwest, this is south and that is west. So that's midway here, and that's basically 225 degrees on the third quadrant. Okay. Now after that, well, let's use our unit circle trigonometry values for such. What do you think will this be? 2 cos 225 degrees in exact values. What will that be? Calculator, guys, what will that be? Well, we know cosine 225 is what? Negative square root of 2 over 2. Very good. Yeah. So 2, negative square root of 2 over 2 basically is what? Negative square root of 2. Right? Okay. What about here? Since it's in the third quadrant, sine and cosine are both negatives anyways, right? So this is also the same. Negative square root of 2. Now, what do we do with these two? Well, that's the first vector and the second vector. What do you do to get the sum of these two? We're gonna add them together, right? So let's add them together. Then the total vector, this is also sometimes called, in physics, it's also called the resultant vector. Okay, the result of adding two vectors is called the resultant vectors. And how much is this gonna be? What's that gonna be in here? -3 minus square root of 2 for the x component. And this will just be what? 0 minus square root of 2. It's just basically negative square root. So that basically it has the adding of vectors already. Okay, let's read our step number 2. Okay, Paula.
Magnitude equals square root of a to the
Yeah, a
square
squared.
root plus b to the square root.
Thank you. Square. Okay, square. Okay. So anyway, but yes, put in here magnitude is equal to what? Square root of this. That's your a. Okay. Square it. So -3 minus square root of 2 squared plus this squared as well. Okay, now let's see. We're basically in here, we're basically just gonna use our calculator for such. And here it is. So what's the magnitude, guys? Square root of, what's the first parenthesis? -3 minus square root of 2. Square it. Okay. Plus, the other one is, what's this? Negative square root of 2. Square it as well. Okay, oops. Okay, so approximately we got the answer in here as such. What's this? 4.64 approximately. All right, so this is approximately 4.64 miles. That's the distance traveled. However, what's the direction for such? So let's put it in here to get the direction. Step number 3. Let's read this one in here, okay? Chloe, go ahead, please.
Direction.
Theta reference.
Reference equals b over a.
Sorry, I forgot this one. Tangent inverse, all right? Don't forget. Tangent inverse of.
And the inverse of absolute value b over a and consider all the equations.
Thank you. Okay, bless you. So that's it. What we're gonna do is as such. So let's get first the reference angle. Reference angle is equal to what? Tangent inverse of the absolute value of what? B, yeah, that's negative square root of 2 over A, -3 minus square root of 2. Okay, so let's see. What's that gonna be? Let's consider that one in degrees, okay? Put it in here as such. Tangent inverse absolute value, okay, of B. Let me just copy this, negative square root of 2 over, okay, A. So I'm just gonna copy this and put this in here, okay. All right, okay. I would want to see that one in terms of degrees for now, okay. If I click on degrees, it gave me how much of an angle? 17.70, what's that? 6 degrees, right? So in terms of degrees, that is how much? 17.76 degrees. Mr. Deal, 17.76 degrees is in quadrant 1. However, what quadrant is this?
Third quadrant.
Third quadrant, very good, right? Negative, negative, right? So if that is in third quadrant, and we know that this is just the reference angle, we add this to what?
180.
180 degrees, right? So plus 180 degrees, and that's gonna be the actual angle for our case, okay? So that's it. 180 plus 17.76 degrees. So here it is. Let me add it in here. Control C, put it in here. Control V. And what's that? Plus 180 degrees. Okay. And what's that going to be? 197.76 degrees. Okay. So let's put it in here. 197.76 degrees. Now, how do we verify? Mr. Deal, can we verify if we got our answer right? So here it is. How to verify if we got our answer right. First of all, your R is equal to what? What's the distance again? 4.64 miles, right? So 4.64 miles. Okay. So yeah, almost correct within that radius. Okay. What about the angle? Well, here it is. I'm gonna go here, go to angles, and make sure it's in degrees. And let's see. What is our angle again? 197 degrees. So where is that 197 degrees? So this is what I'm gonna do. I'm gonna draw it in it's an orange, purple, green. So this is where it starts. Where's the end? This is the end. Okay. Good. So I'm gonna connect those two. Okay. So if I connect these two, so it's better definitely to have like a straight edge for this one. This is basically our resultant vector. What do you notice about the resultant vector? How much of an angle is this one in here? From here to here, what is that angle? Yeah. So we can say that that is approximately 197 or 198 degrees. Alright, so we can say that this angle here is approximately 198 degrees. Okay, so as you may notice, what did we do? First vector, the head of the second, the tail of the second vector is on the head of the first vector. Draw the second vector. Now from the start to the end, draw a resultant vector. See your R, it should be equal to the distance, magnitude. See your angle, it should be equal to the direction. Okay? Again, we're gonna continue with this tomorrow, but you know, it's giving you an idea of to get the magnitude, direction, x component, and y component of our vectors. Again, any quantity with magnitude and direction. Thank you, guys.